Hello there. I trust all of you are doing so well, just as I am doing here also. We have another great opportunity to study science through our e-learning platform once more. In our previous weeks, we've looked at some interesting lessons in integrated science. And this particular lesson promises to be yet another interesting one. So just as you've been doing always, I want you to pay attention, take your notebooks, and get ready for another interesting edition of our science lessons. Are you ready? Great. I hope you are. So, what are we going to look in our lesson today? Today, we are going to focus our attention on conversion of energy. Conversion of energy. And this would focus on forms of energy. That is part 2. Part 2 of forms of energy. In part 1, we focused on the various forms of energy we have and then zoomed in on mechanical energy alone, where we saw potential energy and kinetic energy. I gave you some questions to try your hands on as well, and I trust you did just that. Wonderful. Now let's look at the main objectives for today's lesson. So by the end of the lesson, you will be able to demonstrate how various forms of energy are transformed. Good. So let's start by looking at light energy. What is light energy? So it is a form of energy that stimulates our sense of vision. Sources of light energy could be natural or artificial. Our main natural source of light is the sun, while other sources include the stars, fireflies, glowworms, and the likes. Artificial or man-made light include the hurricane lamps, torches, television pictures, and so on and so forth. So on your screen, you have some of the examples of sources of light. We have the sun, which is our chief source of light. We have the firefly, we have the stars, and the glowworm. So let's look at heat energy. Heat energy is the energy produced as a result of difference in temperature between two areas. Example, burning charcoal to boil water. Let's now look at some sources of heat energy. We have burning firewood, burning candle, burning stove, and sun. These and many more are some of the sources of heat energy. Let's look at electrical energy. It is the energy produced as a result of movement of electrons. So whenever electrons move, electrical energy is generated. Sources of electrical energy include batteries, generators, dynamos, solar cells, and many more. On your screen, you have some of the sources as we mentioned in our previous slide. The battery, as you have there, the generator, as you have there, and a dynamo. Now, if you look at the dynamo, those of you with bicycles, if your bicycle has a light or a lamp, you realize that it has this circular thing, that round thing, attached to it, which produces light based on the rate at which you are paddling it. So if you should paddle it faster, the light becomes bright, especially at night. That is just an example of dynamo. There are so many forms. We have bigger forms, we have smaller, of that also. So let's look at sound energy. It is the energy obtained from vibrating bodies. Sources of sound energy include the loudspeaker, guitar, trumpet, and them all. So on your screen, you have some images of sources of sound energy. You have the loudspeaker there, beautiful one, of course, guitar, and the trumpets. All these things produce sound. Let's turn our attention to chemical energy now. It is the energy produced from the chemical reactions. Any substance that can be used as a fuel contains chemical energy. There's something we really have to take note of. If a substance can be used as fuel, the kind of energy contained in it is chemical. Please take note. Sources include petrol, which is used to fuel a car, food, which keeps us active, burning of coal. Examples of matter containing chemical energy. Examples of matter containing chemical energy. We have coal. Now, in coal, combustion reaction in coal converts chemical energy into light and heat energy. Wood, combustion reaction, that is, whenever it is burnt, the chemical energy there is converted into light and heat energy also. Petroleum, it can be burned to release light and heat energy, or it can be changed into another form of chemical energy, such as gasoline. We have chemical batteries. We all know that chemical batteries store chemical energy, which is then changed into electricity. You have biomass. Now, combustion reaction of this converts chemical energy in the biomass to light and heat energy. We have natural gas, which also does the same thing. Whenever it is being combusted, the chemical energy is converted into light and heat energy. We can talk about food. Food. Whenever food is digested, the chemical energy in there is converted into other forms of energy, which is used up by the cells. The images that would appear on our screen indicate some examples of sources of chemical energy. You have coal, we have natural gas, we have wood, we have photosynthesis. Can talk about propane, can talk about chemical battery, which we use, which are used in our remotes. We have cellular respiration, we have petroleum, we have food, we have biomass as well. So all these are some examples of sources of chemical energy. Good. Now let's look at nuclear energy. It is the energy released as a result of the splitting or fusing of atomic nuclei. That is the nucleus of an atom. Now, nuclear energy originates from the splitting of uranium atoms in a process called fission. This generates heat to produce steam, which is used by a turbine generator to generate electricity. Now, because nuclear power plants do not burn fuel, they do not produce greenhouse gas emissions. Now on your screen, you have an example of nuclear power plants. This is one of the numerous nuclear power plants, and this one is located in Egypt, right here in Africa. Sources of nuclear energy include nuclear fission, nuclear decay, nuclear reactions. So why is uranium widely used to produce nuclear energy? So uranium is the fuel most widely used to produce nuclear energy. The reason is simple. Uranium atoms split apart relatively easily. Uranium is also a very common element, which is commonly found in rocks all over the world. That is the reason why it is used to produce nuclear energy. So on your screen, you have diagrams, examples of diagrams of the uranium elements. Like we said, these uranium elements are found in rocks all over the world. They are not that common. However, it is very easy to split. That's why it is mostly used as a fuel in nuclear power plants. Now let's look at some uses of nuclear energy. 1. Nuclear energy can be converted into electrical energy in nuclear power stations. Sorry. 2. It can also be used to produce very destructive amounts of heat and light energy in the atomic bomb. That's really serious. If you look at how atomic bombs, such as those released in Hiroshima and Nagasaki in Japan, it tells you how dangerous nuclear energy can be. In this lesson, we have considered a number of issues, even though it's a bit short. However, in order for us to really absorb and assimilate all that we've studied, I want us to end here. So what are the main highlights of today's lesson? 1. We've learned that light energy is a form of energy that stimulates our sense of vision. Also, we've learned that heat energy is the energy produced as a result of difference in temperature between two areas. Again, electrical energy is the energy produced as a result of movement of electrons. And finally, sound energy is the energy obtained from vibrating bodies. All the things we've looked at requires you to do further researches, to read widely on it, and to answer related questions also. I'm sure the more you read, you definitely discover more in addition to what it is that I've given you in this particular episode. I want you to answer these questions yourself. Try them. Use them as a form of revision. If you get some wrong, or after you are done answering, compare them to the notes. If you get some wrong, do the necessary corrections. Alright, now I want you to try your hands on these questions. State two sources each of the following forms of energy. A. Sound energy. B. Light energy. C. Nuclear energy. D. Electrical energy. And finally, chemical energy. Thank you so much for being part of this interesting lesson. It's been short, but I hope you learned so much from it. In our next episode, we shall continue with conversion of energy. Thank you and take good care of yourself. See you again.